Hello, in this video we're going to look at how to find the area under a normal curve, and we're given some data here. If we read through this problem, we're given that the general population, we're given a population mean of mu equals 6 and a population standard deviation of sigma equals 10. And so what we need to do is we need to understand a good assumption for the sample mean and the sample standard deviation. Okay, so I'm going to hop over to Wolfram Alpha, and to find the sample standard deviation, I'm just kind of typing out what I'm thinking about here. I'm going to take the population standard deviation divided by the square root of n. All right, so in our problem, the population standard deviation was 10, and n, let's go back to the problem there, n was 321 people. Okay, so whatever we get here, this is going to be our sample standard deviation. So let's figure out what that is. Okay, and that turns out to be about 0.5581. All right, so now what we need to do is we need to take that sample standard, I'll just write this here. This is our sample standard deviation. What we need to do is we need to understand how many standard deviations, or how many, what is our z-score for the value of 7.55. Okay, so let's go back here. So this was our sample standard deviation, and we had to find our z-score. We had a observation of 7.5 minus the mean divided by the sample standard deviation. Okay, so that's going to be our z-score. So let's hit enter, see what we get. And that value is about 2.69. Okay, that's our z-score, 2.69. So let's go over here and type in 2.69. Take a look at the picture. So, we've got a z-score that's way up here, and the area under the normal curve that sits to the right of that z-score, it's darkened in there, that area turns out to be 0.0036. So it's, if we move this over and look at a percent, it's about 0.36% of the data, or the area under the normal curve, lies to the right of that z-score. So that's pretty extreme. That's a pretty extreme z-score that we have our hands on. It's way out in the tail, and so I would like you to think about that as a very extreme sort of value. But anyways, the result there, the area is 0.0036. Let's go back to our problem. 0.0036. Now the problem says round to 3 decimal places, so that would be a 0.004, and that's the answer.